Hello. For our seventh exercise, we will create a particle system. We'll talk about classes and objects, and we'll also take a look at reverb, which is an audio effect that is quite useful. So, as a sound, I found a bleeping sound that I like. So I downloaded it, and I will add it to my sketch. And once it's added, I will just retrieve its name, select all, copy, and I'll rename this exercise. I'll call it Exercise 7 ParticlesReverb. So now I will create a sound object and I will load the sound. So I'm going to say let my sound, and then I will create a function preload, and here I will load my sound equals load sound, and then I open parentheses, I open quote, I put the sound file name, close quote, close parentheses, semicolon. And then let's create here mouse pressed function. But just trying to economize a little bit the lines of code because we'll have a bit longer code than usual here. So on mouse press, we'll play that sound. We're going to say my sound play, right? So far, so good. Now, let's discuss a little bit particle systems. So particle systems are systems in graphics where you have particles, which can be any graphical object, being emitted, so being born, and then having an autonomous behavior, like, for example, moving in a certain direction. And particle systems, typically, they're created with classes and an object's logic. So in most programming languages, obey to a paradigm called object-oriented programming, where you have classes and objects, and each class has methods and properties, and methods. So preload, for example, is a method. It has these parentheses which allow the method to run and with certain properties, and properties do not have that. They're just kind of characterization elements. My point here is not to discuss object-oriented programming in depth, it's just to exemplify how that can be beneficial for us. So to have multiple elements being drawn on the screen is kind of, if the elements look more or less the same and behave more or less the same, that's a good use case for creating a class. So to create a class, I'm going to use the keyword class, and usually classes start with a capital letter, so I'll just name it particle. So this is kind of the template for each particle, how the particle behaves. And typically in a class you also have, like, you have a setup and a draw in the main sketch. You also have usually a setup and a draw in the class. It's just that the setup is called a constructor, and the draw, any other function, we can call it whatever we want. We can say, sorry, in the constructor I have a typo and I forgot the parentheses. So because it's a method, we should have parentheses, and in draw the same. So this class has two methods: the constructor, which is kind of a setup, and the draw. So usually when we create classes in processing, we follow the same logic of having constructor something that is initialized and draw something that is recurrent that happens over time. So now we could create a new particle. I'm going to create a new particle here. For example, let my particle. And then, for example, when I press the mouse, I can say that my particle is a new particle. Okay? It's a new object of the class particle. And it will be created with any instructions we give it in the constructor. So let's say that I want the particle to be born where the mouse is. Well, then I would create a variable for the x and a variable for the y, and I would associate those variables with the mouse x and mouse y. I could say, but to create a variable, I would inside a particle, we need the keyword this, because it's the variable of that class. So this x equals to mouse x. We're assigning to mouse x to the variable x. And we're going to say this y equals mouse y. Okay? So then we want the particle to look like a circle. So then we say that when we draw, we're going to draw a circle with this dot x and this dot y and with a diameter of 20 pixels. Okay? So with the mouse pressed, we actually draw the circle, but it's not being drawn yet. It will only be drawn under draw. So we can say here, my particle draw. But the problem is, we are asking the particle to be drawn at a moment when the particle hasn't been created yet. So this will create some kind of strange behavior. It's not the typical behavior. We want to work a little bit more on that. So yeah, now we get an error because a particle is being drawn that doesn't exist yet. It only exists when we press the mouse. So usually with particle systems or with multiple objects of the same class, we want the particle not to be just a single item, but an array of items. Okay, and we want, when we create a particle, we want it not just to be created, but to be added to a group of particles. So instead of having here my particle right away, let's create a temporary particle. I'm going to say let let's say new p to be a new particle, and then I add that new particle to my array of particles. My particle dot push. Push means add in terms of arrays, new p. So I create a new particle and then I push it to the array particle. So as we've seen before when we discussed arrays basically are lists of items, right? And in the beginning there's nothing, there's no particles there, and then we add it. And here we cannot ask to draw something when in the beginning there's no particles, so we need to ask the computer, in this case P5, how many particles do I have? and then we ask to draw them all. And if there are 0 particles, none get drawn, which the error that we were getting is exactly that. We're asking to draw a particle that doesn't exist yet. It just gets created when we press the mouse. So this draw needs to be under an if, under a for loop. And the for loop goes from I, which is 0, to I, which is an initial I is 0. The maximum I is the length of the array. So how many particles there are? My particle dot length, right? And then we go from 0, 1 by 1, 0, 1, 2, 3, until we reach the length of the array. So I plus plus. And then we put the draw under that for loop. Now, this makes more sense. We draw each particle, and to represent each particle, we need the array operator, which is the square bracket, and then an I. Okay. So let's try this out. We draw one circle, another circle, another circle, another circle, another circle, another circle, and so forth and so on, right? So actually, when we press the mouse, we could check what is the size of the array. So we could print my particle dot length. Now we have 1. Now we have 2. Now we have 3. Now we have 4. Now we have 5, 6, 7, 8, and so on, right? So recapping, to create a particle system, so we can consider this kind of family of circles a particle system. We create a class called particle. That class is composed typically of 2 functions, like our main application is composed of 2 functions. You can think of a particle or a class as a mini application, right? And it has a setup, which is called, in the case of a class, is called a constructor, and it has a draw. And the constructor gets called, for example, over time, or in this case, it's over the mouse press, and the draw is called in draw. And when we draw, we need a for loop to draw all of the objects of that class. So classes are very useful when you have big systems, like let's say a game where you have multiple characters. Each character can be a class, so that is ideal to organize the code. And quite often we put classes in their own files so that the code is much more organized. So when you say you want to work on character X of a certain game, you go to that file, to that class, and you define how that character behaves. Okay. So to do it, we need a few steps. We need to create an array, which at the beginning it will be empty. There's going to be nothing there. And then we need to find an event under which the new particle gets the new item gets born, and we call it any temporary name. I called it new p equals new particle. Then we add that by calling the new keyword associated to that class. The constructor gets triggered, so that immediately generates these 2 variables with these mouse values. And then we add this particle to my kind of family of particles, which is the my particle array. And we add it with the keyword push, with the method push. And we push the new p to the big family of particles, right? And with print, we're just checking that it's being added and that everything is fine. And then to draw it, we need a for loop, because we're not just drawing one particle. We might be drawing 1, we might be drawing 200. How many? How do we know how many we're drawing? With the keyword length, or the property length of the myParticle array. And the for loop is very useful because it lets us, as we say, sweep through the array from 0 to its length, right? And the length in this case increases by pressing the mouse. So that's quite useful. We have quite a few particles. For the moment, it's a little bit boring because the particles don't do anything special. But now let's create some animation for the particles, right? Okay, so let's say that the particles, for example, have a certain animation that they go up on the screen. And we can actually start making this a little bit better looking. Let's have a black background, and let's have green particles. So for example, fill 02550. So RGB where G is 255. So now we have the particles there, right? I'm going to save my project. Once in a while it's good to save it, especially because later on we're going to add Reverb, which I've noticed is very processor intensive and creates crashes sometimes, so it's good to save it. So now we have a particles, but the particles are a bit boring. They're not doing much, right? Let's animate them. So to animate them, let's create here a few variables for the particle. Well, actually, two variables. We can have a this dot speed, and this could be random. For example, it could be random speed between, I don't know, 1 to 10, for example. Okay, and this is kind of a variable that we're going to add to whatever axis we want to animate. Let's say we want to animate the x-axis, right? That they go, let's say, up in the screen, in the window. Then before we draw, we can say that this dot x plus equal, if you wanted them to go up, it's this plus I, and if you wanted to go up, it's minus equal, right? Minus equal this speed. It's in the y-axis and it's minus. Okay, let's see how. So here we see different particles moving at different speeds, right? Great. So kind of the graphical element of our project is more or less done. So in more complex particle systems, you probably have to start deleting some circles, because there's only there's a limit to the amount of particles we can generate. But I'm going to keep this exercise simple. I will not delete any particle. I'll just keep accumulating them. But for a more complex exercise, it would be good practice to delete them. We could erase particles, but I'll keep it simple for now. And actually, just for a little bit of fun, because we haven't used that, we can also have, we can animate the alpha channel. We can say by default the alpha is full, is 255, but we could have this alpha also decrease with the speed. So you could have this dot alpha minus equal this dot speed. So how would that look like? I forgot to add the alpha to the field, so I need to have here this dot alpha as our alpha channel. It's the fourth parameter of RGB. It's called RGBA, RG, red, green, blue, and alpha, right? So now here the slower they move, the slower also they become transparent. And this alpha will then go to negative values, but then it will be invisible anyway. So we could limit that decrease, or we could just keep it like this. It works fine anyway. Okay, now let's work a little bit on the sound side of things. So let's add a reverb, and let's also map the reverb to, for example, the speed of our particle. Okay. So let's take a look at reverb. So reverb is one of the main elements of the P5 library. So sound library. So we already looked at oscillators, FFT, amplitude, sound file, delay, and filter. And now we'll take a look at reverb. And convolver is a kind of reverb. So that covers most of the main aspects of the sound library. Of course, there's much more to look into, but I'm just considering the kind of the main, functions of sound library. And the reverb basically it adds depth to a sound through a large number of decaying echoes. So whereas the delay is an echo that repeats every few milliseconds or seconds, the reverb kind of creates this kind of continuous wave of echo. It's a different kind of echo, as you will hear. So what we need for reverb, so we need to either disconnect if you just want to hear the reverb, or can keep it connected and then connect the reverb, and then you can set the reverb to certain settings. And the settings usually are the seconds that the reverb lasts, the decay rate, or how long the percentage of decay with each echo. It's a bit like the feedback in the delay, and then is it reverse or non-reverse. These are all optional. Usually I never play with reverse, that it plays it backwards. It doesn't sound natural, so I always play the reverb forward. So imagine reverb as the acoustics of a space, where if you're in a cathedral, for example, large space, you have a lot of reverb, and if you're in a small space, in a small room, it has very little reverb, or it's very dry, as we say in audio. So we create it like usual. We create, for example, I'm going to call this reverb my rev, for example, okay? And I'm just gonna put the console just a tiny bit smaller. I can have only one line of code. And on setup, I can say my rev equals new p5.reverb. Sorry, p5.reverb. Okay, so again, now we see the kind of logic or coherence in the programming, that we have a new class reverb, a new object of the class reverb. And now we have to set it up. How do we set it up? Well, at first we can set it up here on setup, but later we want to map it to the particle. Okay, so first we need to connect that reverb to the sound. My sound connect. Later we can also disconnect the sound from the output to hear just the reverb. But first I'm going to connect it. Connect my rev. Okay. And eventually we'll have to set it. But let's hear now now you hear, if you pay attention, you hear the reverb with a kind of a, it sounds more echoey. It sounds like it's in a space. It doesn't sound so dry as before, right? And we can change the default value. So the set by default, the seconds are 3, so the reverb lasts 3 seconds. The maximum is 10 seconds, and the decay rate, the default is 2%. With each echo, you hear 2% of the previous. So I will just change the duration. I will just change the duration. I'm going to set my rev dot set 10. Let's say let's use a maximum, and I'll do another save just to make sure it is saved. This is a long reverb, and let's put a short reverb. So very short, and I can even put it 0.1, even shorter, right? Like this is almost like the normal sound. Great. So let's try disconnecting the sound, just to demonstrate what is to hear just a reverb without the original sound. And let's set it to the default of 3 seconds. You just hear this ghost, the ghost of the sound. You don't hear the real sound, right? The original sound. And if I put it to 10, you'll see that it's this kind of long and tenuous tail. So, but I like I don't use disconnect because I like to hear the original sound and the reverb itself. Now we can map the speed to, because the speed goes between 1 and 10, I can use the speed of the particle to set the reverb, to set the duration of the reverb, right? So we could remove this myRev set 10 from the setup, for example, and on mouse pressed, before we play the sound, let's set the reverb to the new P. Because we created a new P, automatically a speed gets created. Let's map that speed to the duration of the reverb. But actually, I wouldn't put it in this line. I think it's more coherent to add it on this line after we create the particle. Then we could set it to new P, and now we can get the new P speed, because after it's created, it's calculated in the constructor, and now we can access it. Okay, and why I moved it here is that from now on it doesn't make sense to call after the new P gets added to the particle array. We don't usually invoke the new P. Then we invoke it through the myParticle and the array operator. So if you want to work on it before it gets added to the array, do it before the push function. So let's a slower particle gets very little delay, and a faster particle gets a lot of delay. I will now save it. Actually, we could put in the console exactly how much is this speed, so that we could have a visibility over the delay. So for example, here, instead of printing particle length, we could print new P speed. And again, if you're dealing with the new P instead of the particle array, then I would actually use this line of code here. It's just cleaner. So very slow. So this is slow and little, it means slow and little reverb. Now longer, so faster and longer reverb. Of course, you could map this to anything, right? I'll just save it again. You can map it to anything, right? Here, when you set the speed, you could have mapped that speed, which goes between between 1, so random between 1 and 10. You could map it the reverse way to 10 and 1. So in this case, the slower particles would have more reverb. It's a matter of taste, and you can map this to anything. You could say that you want them always to have a bit more. It's really a matter of taste. We could continue this exercise, and probably in class we will create variations of this if you want to take it in another direction. But I think for now it exemplifies well the utility of the reverb and also the utility of creating classes for repeating graphical events.